In this video, you will learn how to transform the equation of a conic by rotating the axes by a given angle. Begin by graphing the ellipse given with the following formula. Lower x squared over 9 plus lower y squared over 1 equals 1. Now, imagine rotating the ellipse 45 degrees counterclockwise, which gives us a conic section with a graph that is not aligned with the lower x or lower y axis. The equation 5 lower x squared minus 8 lower x lower y plus 5 lower y squared minus 9 equals 0 represents this ellipse. A new coordinate system could be introduced with the same origin, but the lower xy coordinate system is also rotated 45 degrees counterclockwise. In this coordinate system, the rotated ellipse has a major axis on the new capital X axis and a minor axis on the new capital Y axis. We can now develop the rotation of axes formulas, which allow us to transform the second-degree equation in lower xy into an equation in the new capital X capital Y system of a conic that is familiar to us. We will use the generalized equation a lower x squared plus b lower x lower y plus c lower y squared plus d lower x plus e lower y plus f equals 0. Let the new capital XY coordinate system be a rotation of the lower xy coordinate system about the origin by angle theta. Let P equal some point at a distance r from the origin. We can represent the point P as the point lower xy on the original coordinate system or capital XY on the new coordinate system. Next, we will define angle alpha as the angle that r makes with the new capital X axis, which means that alpha plus theta is the angle that r makes with the original lower x axis. We can now represent point P in polar coordinates using the following relationships. Lower x equals r times cosine of the quantity alpha plus theta, lower y equals r times sine of the quantity alpha plus theta, capital X equals r times the cosine of alpha, and capital Y equals r times the sine of alpha. Now, we can derive the rotation of axes formulas. We will start with the lower x term and write the cosine identity for a sum. So, we have lower x equals r times the cosine of the quantity alpha plus theta, which equals r times the quantity cosine of alpha times cosine of theta minus sine of alpha times sine of theta. Next, eliminate the parentheses and group r with the alpha terms. So, lower x equals the quantity r times cosine of alpha times cosine of theta minus the quantity r times sine of alpha times sine of theta. Then, substitute according to the relationships capital X equals r times cosine of alpha and capital Y equals r times sine of alpha. This gives us the rotation of axes formula for lower x. So, lower x equals capital X times cosine of theta minus capital Y times sine of theta. We can then duplicate this process for the lower y term. Begin by using the sine identity for a sum. We have y equals r times the sine of the quantity alpha plus theta, which equals r times the quantity sine of alpha times cosine of theta, plus cosine of alpha times sine of theta. Next, eliminate parentheses and group r with the alpha terms. So, lower y equals the quantity r times sine of alpha times cosine of theta, plus the quantity r times cosine of alpha times sine of theta. Then, substitute according to the relationships as before to get lower y equals capital Y times cosine of theta plus capital X times sine of theta. Suppose that the lower x and lower y axes in the rectangular coordinate plane are rotated through an acute angle theta to produce the capital X and capital Y axes. We can solve for capital X and capital Y in terms of lower x and lower y, and doing so tells us that the coordinates lower xy and capital XY are related according to the following equations. Lower x equals capital X times cosine of theta minus capital Y times sine of theta, and lower y equals capital X times sine of theta plus capital Y times cosine of theta. Or capital X equals lower x times cosine of theta plus lower y times sine of theta, and capital Y equals negative lower x times sine of theta plus lower y times cosine of theta. Now let's try an example. Show that the equation 2 lower x squared plus 3 lower x lower y plus 2 lower y squared minus 1 equals 0 represents an ellipse aligning with the coordinate axes that are rotated by 45 degrees. Start with the rotation formulas, substituting 45 degrees for theta to get lower x equals capital X times cosine of 45 degrees minus capital Y times sine of 45 degrees, and lower y equals capital X times sine of 45 degrees plus capital Y times cosine of 45 degrees. We know that cosine of 45 degrees is equal to the square root of 2 over 2, and we also know that the sine of 45 degrees is the square root of 2 over 2. Therefore, we can rewrite lower x as the square root of 2 over 2 times the quantity capital X minus capital Y, and lower y as the square root of 2 over 2 times the quantity capital X plus capital Y. Now that we've solved for lower x and lower y, we can substitute them into the given equation 2 lower x squared plus 3 lower x lower y plus 2 lower y squared minus 1 equals 0. This gives us 2 times the squared quantity of the square root of 2 over 2 times the quantity capital X minus capital Y plus 3 times the quantity of the square root of 2 over 2 times the quantity capital X minus capital Y times the quantity square root of 2 over 2 times the quantity capital X plus capital Y plus 2 times the squared quantity of the square root of 2 over 2 times the quantity capital X plus capital Y minus 1 equals 0. Next, simplify the equation to capital X squared minus 2 capital X capital Y plus capital Y squared plus 3 halves times the quantity capital X squared minus capital Y squared plus capital X squared plus 2 capital X capital Y plus capital Y squared equals 1. Combining like terms results in the equation 7 capital X squared over 2 plus capital Y squared over 2 equals 1. This combined equation is the equation of the ellipse represented by the given equation when its graph is rotated by 45 degrees.